basic mathematics for KS5 physics, and the topic today is indices. Okay, indices, it's the plural of index, and it's to do with mathematical numbers, with numbers that have exponents or powers, that have a to the power b, p to the power q, 2 to the power 4. So this is, when these numbers interact with each other, how do they interact, and what are the laws under which they are allowed to interact. So the first law is power addition. First law is power addition. If we've got x to the power m multiplying with x to the power n, it would become x to the power m plus n. Now, please note, if it's x to the power m times y to the power n, it wouldn't mix. If it's x to the power m times y to the power m, it wouldn't mix either. So it has to be the denominator, the base power, the base has to be the same, and the power can be different. So if the base is same, the power can be additive. So the base has to be same, and powers will add. So I'll show you an example. X to the power 6 multiplied by x to the x cubed. It'll be x6 plus 3 equals x9. And if we've got x to the power 10 times x to the power 10, it'll be x to the power 20. X to the power 5 multiplied by x to the power 25, it'll be x to the power 30. And if it's 5 10 times to the power 5, 10 multiplied by 5 to the power 40, it'll be 5 to the power 50y, because 5 times, so now I'll demonstrate it. 2 times 2 to the power 2 multiplied by 2 to the power 2 would actually be 2 times 2 times 2 times 2. It'll be 4 times 4 equals 16, and we all know 16 is 2 times 2 times 2 times 2, and so in actuality it's 2 times 2 to the power 4. It's going all the way back. So that's how things are for this. And the other rule second rule is exponent multiplication. And exponent multiplication, something like x, if it's just like, it'll be xab. That's it. So if it's x3, x cubed, bracket closed, whole 5, it'll be x15. Now, we move on to a few examples. So if we've got x, unbelievable, it'll be x45. If we've got 3 quadruple whole pentupled, it'll be 320. So that's that. This is the simplification explanation of the law. And if we had y times 10 whole quadrupled, it'll be y 100. And then if we had 5 to the power 9 times 50 whole power 50, so 5 exponent 9 whole exponent 50, it'll be 5 whole exponent 450. Now we'll move on to some exercise questions. The first question I'm going to pop before you is p exponent a multiplied by p exponent b. The second one would be 3 exponent 2, 3 squared times 3 pentuples. The other one would be a quadrupled times a pentupled. And then c to the power 21 times c to the power 50. So it'll be, this one would be p a plus b. This one would be 2 plus 5 equals 3 to the power 7. This one, you don't need to write the digits, just this answer is fine. So, and then this one would be 4 plus 5 equals a9. And then this one would be c21 plus 50 equals c71. Now we move on to k to the power 80 times k to the power 70. That would be 150 to the power 150. The last example in this case would be b exponent 200 bicentupled times pentacentupled, b exponent pentacentupled. It would be b 200 and b 700. There we go. That's that. And then the other exercise, I'm going to flip it, and it would be exercise 2. So I'll use the same. And the first question will be p exponent a whole power b. So it would be p exponent ab. The second one would be a quadrupled whole cubed, and that would be 4 times 3 equals a 12 to the power 2. Second one would be 5 to the power 10 whole hextupled. It'll be 5 10 times 66. It will be 5 to the power 60. So 5 times 60. So 5 multiplied with itself 60 times. This last, second penultimate one would be y squared to the power 7 with y 14 and then 9 to the power 100 whole quadrupled, decadupled, and that'll be 9 . There we go. So that's 900 times 10. There we go. So that's that. And basically what I'm trying to tell you is whenever we've got something x to the power n, x is the base, n is the exponent, or commonly known as power. Right? And so sometimes we can get questions like 5x8. So in that resembles x n. So if we've got 5x8, 5x to the power 8, so that's 5 times x to the power 8. In actuality, it is x to the power 8. That's what it is. So in actuality, it's 5 times x times x times x times x times x times x times. So that's, I should have chosen a different letter. So 1x, 2x, 3x, 4x, 5x, 6x, 7x, 8x. So 5 multiplying with itself 8 times, and then multiplying with 5. So that's 5x to the power 8. That's how things are. So we could also write it as cx to the power n. So in this case, 5b9, b is the base, 9 is power or exponent, and 5 would be the constant factor, k. So that's that, and that's pretty much it, to be honest. And yeah, because you always have to know the difference between x4 and 4x, because x4, x to the power 4, is x times x times x times x, x multiplying with itself 4 times, and 4x is x plus x plus x plus x. So that's the difference. This is the difference between, and that's how things are. So this concludes our little escapade in understanding the two basic laws of indices, exponents, and it's what will help us to work our way towards exponents and logarithms. And these two laws are rudimentary, very fundamental, and need to be learned for triple award for GCSE science, as well as, of course, for AS and A2 physics. And thank you very much for watching this video about the laws of indices, and I hope it'll help you in gaining an in-depth command of numerical questions in all branches of physics. Thank you very much for watching this video. If you have any questions, please do not hesitate to post them down below in the comment section, and I'll try my best to answer them. Thank you.